Hello everyone, if you're wondering what this video is, let me briefly explain. In my pre-AP chemistry class, we often come across questions that are very intriguing, but generally we don't have the time to answer them. So I'm taking my time to research them and hopefully answer them all. Let's get started. Question 1. How do maglev trains stop? So the first thing you need to know about maglev trains is that they don't ever touch the track because they hover using magnets. This is self-explanatory as you can see in the name. Since the train doesn't touch the rail, it can't use any sort of motor or engine to move, so instead, the train uses magnets for propulsion. Sometimes it uses the exact same magnets to propel the train as the magnets that are used to carry the train, but that just depends on the specific model. A common misconception is that the magnets on the track or on the train physically turn to push the train in the direction that it needs to go, but that's not possible as a magnet does not have the energy to push an object out of its own magnetic field and into another. Instead, the train would just sit between the two magnetic fields or stick to the side of a magnet. Pretty much, you'd end up with a broken train. The way that the train actually propels is similar to that of a motor. The magnets in the maglev rail are electromagnets. The difference between a magnet and an electromagnet is that an electromagnet can be turned on and off, and you can switch its polarity since it's actually powered through electricity. The simplest way to explain how the train is propelled is that the electromagnets in the rail switch polarity at a variable rate to send the train in a given direction. For an illustration, we'll say that the north polarity is blue and that the south polarity is green. If the electromagnets in the rails alternate green, blue, green, blue, green, blue, the green magnets in the train will be drawn to the blue electromagnets and vice versa. As soon as you switch the alternating pattern on the rail, the train will need to move ahead to catch up with the changing polarity. Now that you know all that information, answering the original question of how to stop a maglev train becomes very simple. Just as you would speed up the train by increasing the rate of changing polarity, you would slow down the train by decreasing the rate of changing polarity until you come to a complete stop. Question 2. What caused the shadows in Hiroshima? The bomb that was dropped on Hiroshima had a core of uranium-235. This is a very radioactive isotope of uranium that has a half-life of about 700 million years. The way that the bomb was detonated was by colliding two masses of uranium-235 and creating nuclear fission. The bomb detonated with a force of 15,000 tons of TNT. It released thermal radiation all over the city, which is actually what caused the shadows. To best understand how the thermal radiation made the shadows, we will compare it to the sun. Imagine you go to the beach to get a super intense tan, but you forget to take off your shirt. When you take off your shirt, the spot where your shirt was will obviously not have tanned, since the shirt blocked the UV rays from reaching your skin. This is similar to a radioactive shadow, because when the bomb detonated, it bleached everything in the area. The only things it did not affect were anything that was covered by something thick and dense enough to stop radiation. In the pictures of flash burns and shadows that you see from Hiroshima, the dark part of the image was blocked by an object and the light part of the image was exposed to thermal radiation. Question 3. What chemicals are in a burp? Burping and flatulence are nearly the same, but different at the same time. The difference is actually what determines the answer to this question. A burp is when you swallow air and it needs a way to escape. The contents of a burp strictly depend on what you've consumed in the last few hours. Flatulence is different because that is after the contents have been through the digestive system. The elements in flatulence, on average, consist of 59% nitrogen, 21% hydrogen, 9% carbon dioxide, 7% methane, and 4% oxygen, as well as any other chemicals in the food you've consumed. Knowing that is probably more interesting than knowing the contents of a burp, saying as a burp is just oxygen and odors. Question 4. Who discovered baking soda and how? Baking soda, or sodium bicarbonate, is a chemical that has very many uses. The chemical formula of baking soda is NaHCO3. To our knowledge, baking soda has been used regularly since 3500 BC. Egyptians supposedly used baking soda for cleaning and to wrap mummies. They didn't have a pure form of baking soda, but they did have another chemical called natron that was comprised of mostly sodium carbonate. It wasn't until 1843 that a chemist named Alfred Bird discovered baking soda. His wife Elizabeth was allergic to yeast, so he wanted to find a solution for baking that she wasn't allergic to. That's when Bird discovered sodium bicarbonate. Only 3 years after that, the Arm & Hammer brand was created and it lives on to this day. Question 5. How much paper does it take to stop radioactivity? This question is extremely difficult to answer for two reasons. First of all, there are many variables such as the type of radiation and the type of paper. The other reason this is difficult to answer is because no one has tried it, but I will do my best to estimate the answer. The reason that lead stops radiation is because it has such a high density and atomic number. The density of lead is 11.34 grams per cubic centimeter. In comparison, the density of paper is about 1.2 grams per cubic centimeter. In the mind of someone who is not a scientist, and according to Google, the radiation stopping ability of lead is about 9.45 times that of paper. This would mean that you need 9.45 times the amount of paper to stop radiation as you have lead. So if that was confusing, this should be simpler. It takes 1.3 feet of lead to stop gamma rays by a factor of 1 billion. If you multiply that number by the difference in radiation stopping ability of lead and paper, you get 12.285. This means that you need 12.285 feet of paper to stop radiation, and according to my calculations, that would be 36,855 pieces of paper to stop gamma rays. Question 6. Who invented plastic and when? Plastic has a very long history dating back to 1284, which is the earliest natural occurrence of plastic that we have found. Then between 1862 and the early 1900s, many scientists came up with different plastic-like substances. It wasn't until 1909 that a chemist named Leo Baekeland invented a very pure form of plastic, as we would use today. This was the first form of plastic to be publicly accepted and appreciated. Even though he was not the only one to discover plastic, he is the man most associated with it. Question 7. What are paper straws coated with? The way that paper straws are made is quite simple actually. In a paper straw machine, rolls of 1-inch wide paper are placed on a spindle. There are generally about 5 rolls at a time to make the straw thicker. The strips run from the spindle on a series of wheels to an adhesive. The adhesive is usually made from the same chemicals as Elmer's glue. The chemical formula for Elmer's glue is C4H6O2, so it contains carbon, hydrogen, and oxygen. After running through the adhesive, the strips of paper make their way to a spinning metal rod where they are wrapped around it very tightly. The paper is wrapped so tightly that the glue dries within seconds. Once the straw gets long enough, it is cut to length and ready to ship. I hope you have all learned something from this video, and I'll see you next time.